যত মানুষকে ঠগে আলু বিক্রি করেছেন সবার কাছে টাকা ফেরত। যত মানুষকে
Assalamu alaikum. I can see 22 have joined out of 36. Should I start?
Assalamualaikum, sir.
Walaikum assalam. Are you all listening?
Yes, sir.
Yes, sir.
Okay. And from today we will start the syllabus of midterm. Okay, midterm syllabus.
Okay, sir.
Are you all listening?
Yes, sir.
Can I see your face, everyone?
Yes, sir.
Yes, sir.
No one is turning on the camera.
Right hand.
I have turned, sir.
Okay, Hassan al Haq, I can see. Mahmudur Rahman, Shakibul Hassan, Tasneem Rafi, Sharifud Jaman, Ifat Jahan, Muqtadir Rahman, Ahmedullah, Imran Hassan, Maminul Islam, Himel Ahmed. Mizanur, I can't see. Abdul Momin, I can't see. Salman. Shajaul, I can see. Mehdi Hassan, Abzalur. Okay. Can you tell me what was the last topic of our first term exam?
AMFM, sir.
Sir, AM.
AM/FM. Okay. I think you can remember we have some discussion on the lab class regarding modulation factor, right?
Yes, sir.
Modulation factor discuss in lab class, sir.
Modulation factor in the lab
Sir,
class. Yes.
The lab
sir,
night, sir.
sir, what is limiter, sir?
AMFM, sir.
Sir, AM.
Uh, Limiter is a circuit used in FM receiver to cut down unnecessary amplitude of the received signal due to the noise effect.
Hello, sir.
Yes.
Sir, I couldn't answer, sir. Line of sight or light of sight? This question.
Line of sight. Line of sight, that means the uninterrupted straight line from transmitter to receiver. That means there shouldn't be any obstacle between transmitter and receiver. There should be a straight line of connection. You understand?
Okay. Yes, sir. Yes.
Suppose you are looking at something and uh, uh, the object you are looking in between you and that object, if something appear, then you can see that object, right? So similarly, electromagnetic wave travels a straight line like light wave, like light ray. So when there is obstacle, the transmission will be hampered. Okay. How many of you don't have lab course?
Me, sir.
Okay.
I don't have, sir.
Marceline too. Actually,
And
Abu Raihan, you also.
Sir, me also, sir.
Sharifuzzaman.
আবু রায়হান তোমার
Okay.
ল্যাব নাই?
ওই রায়হান ল্যাব আছে।
তাহলে আট কিলো যান।
Okay, I think
Sir, lab
four.
complete.
Four students don't have lab course. Actually, actually lab and theory, they are interrelated, you know.
Yes, sir.
Yes, sir.
So
Yes, sir.
since you don't have the opportunity to perform lab experiment physically, that's why what I am doing in the lab class, I am just explaining the theory so that you can understand when you will be doing the lab practically at the campus. So basically what we have seen or what we have discussed in the last lab is a topic of your midterm syllabus. And you know the topic name. The topic name is modulation factor. This one. Can you see the slide?
Sir, someone is
I'm
waiting.
on in
No one is waiting. Look,
Yes,
this
sir.
is the screen I am sharing. And if they join after 15 minutes, they wait. They can wait another 5 minutes, right?
Yes, sir.
Yes, sir.
Okay, listen up. Modulation factor. Hey, those who didn't attend lab or don't have lab course, please listen carefully.
Okay, sir.
Okay, this term modulation factor is related to amplitude modulation. Which modulation this one is related?
Sir, this is related to the amplitude modulation.
Amplitude modulation. Okay,
Amplitude modulation, sir.
so what is the definition of this modulation factor? The definition is here. The ratio, modulation factor is the ratio of change of amplitude of the carrier wave to the amplitude of normal carrier amplitude. It's called modulation factor.
Sir,
So
here
if
normal carrier means signal.
normal carrier means when the carrier is not modulated. That means this one here the carrier amplitude, suppose A. So this is the normal carrier amplitude. No modulation is occurred in this carrier signal. But after modulation, you can see the carrier amplitude is varying according to the message signal, right? So what is the change of the amplitude? That change will be here in the up top side, okay? And in the bottom, what you will write? You will write the amplitude of the normal carrier wave. So the interesting thing is carrier change, the amplitude change in carrier is exactly similar with the amplitude of the message signal, right? Because
Yes,
the
sir.
change will be according to the message signal. So this one, the change of carrier wave is equal to amplitude of message signal. You understand? So we can replace this term by the amplitude of message signal. And at this bottom side, you can write it is the normal carrier amplitude. So actually modulation factor M, it can be written as like this, amplitude of message and divided by amplitude of carrier. You understand? This is the
Yes, sir.
shortest equation for modulation factor. Shortest equation for modulation factor. Okay. Are you getting the point? Hello?
Yes, sir. Yes,
Okay.
sir. We're getting the point.
Okay.
Yes, sir.
Sir, amplitude change of carrier wave equals a message signal.
Equal message signal, not message signal. The amplitude of message signal.
Yes,
Amplitude.
sir.
Here we are talking about amplitude. So in the upside and in this below, both case we are talking about amplitude. So the amplitude change is equal to the amplitude of the message signal. You understand? So
Yes,
we
sir.
can replace this term by the amplitude of message signal. You understand?
আমরা তো এইভাবে বলতে পারি একটা greater than একটা less than আর একটা equal স্যার
Okay, that's okay. That is what is called critical frequency over, not critical frequency, critical modulation factor, over modulation factor, under modulation factor. That is one term. I will show you one short video on YouTube, then you will understand it properly.
Yes, sir. That will be great.
From the textbook, look, here you can see four examples. Example 1, 2, 3, 4. Can you see 4 example altogether?
Yes, sir.
Okay, look at here. These are the carrier signal. This left side, carrier. And in the middle, this is the message signal. For the first example, there is no message. That's why it is written no signal. And in second one, there is a message signal. Third one, another message. Fourth one, another message. But the thing you need to careful here is about the amplitude. because modulation factor is related with the amplitude. You understand?
Yes, sir.
Amplitude. So in the right side, in this side, can you see these are the modulated signal?
Yes, sir.
So these are amplitude modulated signal. You understand? Amplitude is varying according to the message. So amplitude modulated signal. So we are clear about this, I think. First one is the carrier, middle one is the message. So when you are adding these two things, you are superimposing these two things, you will be getting the modulated signal at the right side. Up to this we are clear.
Yes, sir.
Okay. So in the first example, if you see, in the first example, the carrier has an amplitude of A, right? A amplitude. Can you see? Amplitude is defined as A.
Yes, sir.
Okay. And no signal means there is no message. No message means there is no message amplitude. So what will be the change of the carrier if you modulate these two things? No signal,
change.
carrier. The
No
carrier
change, sir.
will remain the same. There will be no change.
Yes,
Yes,
sir.
Are you getting the point?
yes,
Yes,
sir.
sir.
Okay. So look at here. AM wave is exactly
Carrier,
similar to the
wave.
carrier wave. You understand? For the first case.
Yes, sir.
So
Yes,
can
sir.
you tell me, what is the change of the amplitude in this modulated signal, AM signal?
No chance, sir.
No change. Previously, the amplitude was A. Now the amplitude is A. So what is the difference or change? A minus A, right?
Yes, sir.
A minus A means 0.
0,
So at this top side, what you will write? 0.
0.
Yes, sir.
And in the
Yes, sir.
bottom, what you will write?
A.
You will write A. Which A?
A.
This one, the carrier
Carrier
amp.
wave.
Carrier
Carrier.
amp. So 0 by A will give you what?
Input.
0 by A will give you 0, right?
0. Yes, sir. Yes.
That means for the first case, this one, the first case, it is written here when the signal amplitude is 0, the carrier wave is not modulated as shown in figure 16.31. The amplitude of the carrier wave remain unchanged. So look, amplitude of the amplitude change of carrier 0, amplitude of normal carrier A. So modulation factor M is equal to 0 divided by A is equal to 0 or 0%. If you multiply this 0 with 100%, you will get 0%. You understand?
Yes,
Yes,
sir.
sir.
So similarly, for the second example, if you calculate the modulation factor for this, what you will get? What is the amplitude change? Now this is twice A.
2s.
Hey, if you don't understand how 2A or twice A is here, then you have to start from the beginning of amplitude modulation.
Yes, sir.
Do you understand how this 2A is here?
Yes, sir.
Sir,
From
Yes,
this
sir.
carrier
signal
and
or carrier
message?
signal.
Signal, sir.
Because the carrier amplitude was A and message also A. So there will
Yes,
be a change in the carrier. The carrier will be increased by another A and decreased by A, right?
yes, sir.
Yes, sir.
Previously A increased another A. So there will be twice A increment. So this
Yes,
is
sir.
the twice A increment. And previously it was A and there will be a decrement of another A, right? Then it will
Yes,
touch the 0 position, is not it?
Yes, sir.
0 means here. Can you see? It is touching the 0.
Yes, sir.
So if this is twice A, what is the change? Twice A minus A,
Sir,
The
is
one, sir.
A, right? A.
Yes,
A is
yes,
the
sir.
change. And divided by another A, carrier
A.
amplitude. So A divided A will give you 1. 1
1.
into 1
100%.
into 100 is equal to 100%, like this.
Yes,
Yes.
sir.
Yes, sir.
So similarly, this one, for the third case, here the message is 0.5A. So what will be the modulated peak amplitude?
1.5.
1.5A. What is the change? 0.5a.
0.5.
What will be the modulation factor? 0.5 divided by a will give you 0.5.
50%, sir.
0.5, right? This one.
Zero.
This is the
50%.
change, and 0.5a divided by a will give you 0.5. That means 50%. You get the point?
Yes, sir.
Yes, sir.
And for the last one, carrier is same, just like before, amplitude A.
Yeah.
And the message is now 1.5a. So after modulation, the carrier amplitude will be increased and decreased by 1.5a value, right?
Yes, sir.
When it is
Yes, sir.
increasing, it will reach at 2.5a at the top, this value, it will be 2.5. And when the decrement will happen, what will happen? It
Sir,
will
why
cross
here
the zero
increase,
line.
sir,
Yeah,
1,
right.
sir?
Hmm?
Sir, why here increase 1, sir? If this is increase 1.5 and this is increase only 1.
A means one A.
A means
A
1.
means 1a. A means 1a. You
One
understand?
A plus
Yes,
1.5
A
A.
means 1a. A
বুঝতে
means
পারছি, স্যার,
1.
বুঝতে পারছি।
Okay. A means 1a. So 1a and 1.5a increment will be 2.5a.
Yes, sir.
And what will be the decrement? 1a minus 1.5a. That is minus 0.5a. So it will go below the zero level. This one is critical. Understand? Look, it is crossing this zero line. Hello.
Yes, sir, বুঝতে পারছি,
Sir.
স্যার।
Okay. So we have discussed this in the lab, I think, in detail.
Yes.
স্যার, নেগেটিভ হলে ক্রিটিক্যাল, স্যার।
No, negative, that is over modulation. Critical
sir.
means this one, when equal, touching the zero line. Touching the zero. Okay, one thing is important. Look, one thing is very, very important. We have seen that this modulation factor value can be 1. Modulation factor value can greater than 1. Modulation factor value can smaller than 1, right? 3 situation we have seen.
Yes, sir.
You
Yes,
understand?
sir.
So
Yes, sir.
actually just put it in the percentage value, 100% greater, 100% smaller, 100% equal. So 3 scenario, 3. So actually in this 3 scenario, when modulation factor value is greater than 100%, it is called over modulation.
Yes, sir, over modulation, sir.
Over. When they are equal, this is
Critical.
called critical modulation. And when it is smaller, it is called under modulation.
Yes, sir.
And
Yes, sir.
out of these 3, the dangerous one, dangerous means the
Over, sir.
problematic one is this one. This is the problematic one. Over modulation
Over
we
modulation.
don't want, because during over modulation, what happened? During
The
over
signal is lost.
modulation, some portion
Signal
of
is lost, sir.
will be lost. Look, can you see there is an empty space here?
Sir,
Yes, sir.
Yes, sir.
Empty means some positive signal will cross the zero line, that means go to the negative portion, and some negative amplitude will come at the positive amplitude. So these two will be cancelled out that time, and this one will be empty or overlapped. So due to the overlapping, the signal will be lost here. Are you getting the point?
Yes, sir.
Suppose the message was like this. Okay, if these are the in the positive side, right, and these are in the negative side. So if when you are demodulating it, if this item appear here in the negative side, that means it is lost. Are you getting my point?
Yes, sir.
Again, sir, again.
Now understand. Okay. Look, I'm drawing again. Suppose here this is the message signal, and here is the carrier signal, carrier 1. I'm missing the whiteboard actually in the university. It's very difficult to draw. Okay. When they are modulated, actually what will happen? Tell me. According to this, according to this amplitude, here the amplitude will be increased, right?
Yes, sir.
And according to this negative one, here the amplitude will be decreased, right?
Yes, sir.
Okay, listen up. Suppose previously this is the carrier. Carrier is 2, for example, twice A. And this one is 3A. So here the increment will be another 3A, right?
Yes, sir.
So all together, what will be the new amplitude of the modulated signal?
5A.
5A. 5A. Okay. Now look at for the negative one. In the negative side, this portion is also minus 3A, right?
Yes, sir.
Another 3A in the negative, another side. That means minus is representing in opposite direction actually. So from this point, we have to go below or go down to what? To another minus 3A.
Yes, sir.
So if you cross, if you come up to this level, that means you are in 0 position. You have to go another one, right?
Yes, sir.
এই
One, sir,
কথা
voice, sir.
বুঝেন নাই?
Oh, yes, sir. Another.
এই এতটুকু মানে কত?
2.
Up
Sir,
to
yes, sir.
up to
Two,
this
sir.
is 2. And if I go below up to this 0 level, that means I am going down to 0, right?
Yes, sir.
তার মানে আমি 2 নিচে নামলাম, is not it?
আরো 3
Yes,
আছে।
sir.
এখন আমাকে আরো কতটুকু নামতে হবে? কারণ আমাকে তো 2 নামলে তো এতটুকু নামা হলো, up to this,
Yes,
এতটুকু।
sir.
I need to go down another 1. So that means I am crossing the 0 line. You understand?
Yes, sir.
I am crossing the 0 line. So that is the problem. This portion of the signal will be lost when you cross the 0 line. Similarly, same thing will be repeated. Same thing will be repeated here in this way. You understand? So some negative portion will also cross the positive side. So
Sir, I have a
actually,
question in there, sir. Why this signal is mirrored here, sir?
where
Why
is mirrored?
Sir, why this signal? Sir, I mean message signal. Why this message signal is mirrored here, sir?
Okay. So you are telling that why we are copying or there is a mirror.
Mirror of message signal, sir.
Okay, I understand the question. Listen, actually this one is called envelope. You know envelope for posting any letter?
No, sir.
Yes, sir. We had it.
Actually this is called the envelope, like this one. Okay, so what is happening actually? Previously the carrier signal was like this, with a fixed amplitude.
Yes, sir.
Like one, is not it?
Yes, sir.
Okay, suppose this is the carrier signal.
Carrier signal. Okay, sir.
And by the definition of amplitude modulation, what will happen?
No,
The
Change it, sir.
amplitude of the carrier signal will change, right?
Yes, sir.
Okay, so what is the amplitude of this carrier? Here is one amplitude, another amplitude in this side. Do you understand? Because the signal has two options, in top side and in the bottom, right? So if you change here, you have to also change here, because both sides we have amplitude.
Yes, sir.
So actually what we are doing, we are changing the amplitude according to the message signal in this place. Similarly, at this side we have to copy the change, so that you can tell amplitude is changing. We can see amplitude is changing, increasing and decreasing. You understand?
Yes, sir.
You get
Yes,
the
sir.
point? Hello.
Yes, sir.
Because sir, amplitude of the carrier signal is changed, sir.
Yes, amplitude. So if you change at the top side only, that means you are changing 50%, partial
Yes, sir.
half.
Carrier change. Yes, sir.
So we have to change in all. So look, in below it is also constant, and at the top it is also constant. So we are changing below and top both. That is why it is like a mirror relation. Okay, so you get the idea why this segment is empty here,
Yes, sir.
because
Overlap.
they are showing
Overlap.
the message is overlapped. Okay, another interesting thing, look, out of these three, out of this, for example, you will answer. I am going to ask you a question. Listen, for this one, oh sorry, for example one, for example one means this one, first one, when there is no signal. This is the modulated signal, right? AM?
Yes, sir. This is modulated.
Modulated. Okay. So what is the circuit for demodulation here? Detector, right?
Yes,
Yes,
sir.
sir.
It is
So,
detected.
detector actually detect the amplitude change, is not it? Can
Yes,
you
sir.
remember? The
Yes, sir.
function of detector is simple. It just
Detect
detects
the
amplitude
modulation
variation,
variation. Yes, sir.
right? And it cannot
Yes, sir.
even determine which one is noisy part, which one is the original message part.
Amplitude
It
part.
cannot determine that. There is a limitation, right?
Yes, sir.
So now tell me, for the question of for the example one, this AM wave will be demodulated. That time, what will be the demodulated signal? What will be the demodulated signal? It will be a straight line, right? Or it will be nothing.
Yes, sir.
Are you getting the point?
Yes, sir.
Because there is no amplitude variation. So the detector will not detect any variation.
Yes, sir.
Are you getting my point?
Yes, sir.
Okay. For example, two, this one. What will be the variation? The variation will be like this.
Yes, sir.
You get the point?
Yes, sir.
Okay. For example, three, you will also get a variation like this, right?
Yes, sir.
For example, four, look, example four, you will get like this.
So this is bad for us, right, sir?
Yes. Now, what I am trying to explain, did you get the point? What I am trying to say. Now compare them with the message signal. Here, look. For number one, there was no message, right?
Yes, sir.
So look, there is no signal. That means no message is there in the modulated wave. Look, in the example two, there was a message like this, and you have retrieved the message. Can you see? It is similar to this one.
Yes, sir.
Question in three, there is another message like this one, and we have also found a message like this one.
Yes, sir.
But what about four? There was a message like a sine wave, but what we have found? Look, one portion of the message is missing, right?
Yes, sir.
Here, this segment is lost. This one is lost.
Yes, sir.
Why this segment is lost? Because
Because
it is crossing the zero line, right?
Yes, sir.
Similarly, we'll be getting signal like this. One portion of the signal will be lost. And this is not good for us.
Yes, sir.
Because we should recover this message in the receiver. And if we cannot recover it due to this type of modulation, then this is not good. You understand?
Yes, I understand, sir.
Okay. Now here the thing is given. What we have just discussed is given here. Importance of modulation factor. And this is the summary of this paragraph. This one is the summary. Therefore, that means Sutarang, degree of modulation should never exceed 100%. When the degree of modulation exceeds 100%, this type of scenario will be there. You get the point?
Yes, sir.
If you
Yes, sir.
cross 100% modulation factor value, That means you are losing some signal, message signal. আমার কথা কি বুঝতেছেন?
জি স্যার
Yes, sir.
Yes, sir. Then over modulation never be accepted, right, sir?
Yes, over modulation should never be accepted. Why? Because there is a 100% chance that some portion of the message signal will be lost during demodulation. কথা
Yes,
বুঝে
sir.
গেল?
Yes, sir.
Yes,
Clear.
sir.
Sir, it is good,
So,
sir. The critical or sir, under, sir.
yes. So basically critical, okay. Basically critical means critical. Hey, the meaning. Hello. Hey, the word critical. It means critical means সংকটাপন্ন বলে না যে the situation of this patient is critical, that means he is in the line of life and death, right? জীবন মৃত্যুর
Yes, sir.
সন্নিকটে এসে আছে, critical condition. So similar thing, look, it is crossing the zero line, so it is about to cross, it is about to what can I say, lost some signal from here, but it still up to this is okay. But if it is go by point something, there will be a small amount of loss as well. You understand? এই বুঝেন নাই মনে হয়।
বুঝছি স্যার, মানে একেবারে লাইন জিরো বরাবর স্যার, মানে
Yes, you are একেবারে এইখানে এই টাচ করে রেখেছেন, আর একটু গেলেই কি হবে, লস হবে।
লস হবে।
That's why it is called critical. Similarly, we will study another thing in fiber optic communication system, that is called critical angle. Can you remember there is a term called critical angle?
Yes, sir. Krantikon.
Krantikon, yes. The critical angle means we will study it, but I am telling it now actually. Suppose you have two medium, one here is glass and suppose this is air. So definitely glass is highly dense medium, right? Density is higher, and air low dense medium. So if a light ray passes from the air medium to the glass, what will happen?
স্যার আগে ভেদ করবে একটা।
Okay,
এটা
sorry,
কম
I am just explaining in opposite way. Actually, it will be air, and this will be glass.
Yes, sir.
Okay, glass, and this has higher density. It has lower density, and suppose we know the characteristics of light is to travel straight line in this way, right? Straight. Light will travel straight. This is the characteristics of light.
Yes,
Is
sir.
not it? And this straight line characteristics is applicable in a single medium, but when it is changing medium means madhyam, when it is changing the medium, what will happen? There will be some deviation this way or that way, right?
Yes, sir.
And this is called what? Refraction. Protisharan.
জি স্যার, প্রতিসরণ।
Okay. So can you see we are discussing with two different medium. One is glass, another one is air. Suppose you are throwing a light from the glass in this direction. This is the direction. I need to hit at this point. Okay, here. This is the one. So the projected, it's supposed to go in this direction, right? But what will be the actual direction?
So it will be far away from the perpendicular.
Yes, it will be far away from this perpendicular axis. Suppose this is an angle and this angle is 20, and this will be greater than 20, right? Hello?
Yes, sir.
Yes,
This is the
sir.
nature of light. Okay, suppose this one is 40, double, let's say double. Again, I am placing another light ray in this way, in this direction. Now suppose this is 40. So what will happen? It will cross in this way, right?
Yes, sir.
Suppose this will be now 80 degree. Now if I throw a light ray that is in 45 angle, what will happen? Here the angle will be now 90, is not it?
It
Yes,
will be
sir.
sir x
Sir.
90 means the light ray will travel through this boundary of these two medium, is not it?
Yes, sir.
লক্ষ্য করেন যদি 90 ডিগ্রি মেইনটেইন করতে চান আপনাকে লাইট রেটা কোন বরাবর নিতে হবে? এই পাশে আছে গ্লাস and at this side there is air, so you have to go through in this boundary level, is not it?
Yes,
So
sir.
if I say where is this reflected ray, reflected rayটা কোথায়? If I ask you, আপনি কি বলবেন? এটা না বাতাসে আছে না কাচের মধ্যে আছে। It is in the critical situation, is not it?
Yes, sir.
So this
আপনারা আসতে দেরি করে দিয়েছেন, রোগীরা বাঁচানো সম্ভব না।
so this is in the critical situation, and who is responsible for this critical situation? Responsible is this ray, and this ray is
Yes, sir.
here in 45 degree angle. So the 45 degree will be the critical angle. You understand?
Yes, sir.
Due to this 45 degree of incident angle, reflected angle will be 90 degree. So 90 degree means it is neither in first medium nor in second medium. So this is in a critical situation. So this is the critical angle, incident angle, critical angle. So
Yes, sir.
similarly, why we are calling it critical modulation? Because it is not in positive, not in negative. Actually, it is touching the zero. You get the point?
But sir, which is the better, at 98% or 90%?
Okay, actually, you have to keep in mind that you should not exceed 100%. You may close to 90%, 80%, 70%. That is okay. That is okay. But do not cross.
100, sir.
Close to 100 is good,
Yes, I understand, sir.
but not more than.
Yes, I understand, sir. 100 is, sir, very good, sir. If we are exactly 100, then, sir,
There is a risk. What is the risk? Suppose if some noise is added here, then what will happen?
understand, sir.
It will be.
It will be, then you will be in problem, right?
Yes,
Yes,
sir.
sir, understand.
Okay. So look at here. With this formula means this one, modulation factor is equal to amplitude change in carrier divided by amplitude of normal carrier amplitude. You can see there are some mathematical problems, 3 mathematical problems actually, very simple. So here is number 1, 16.1. It is actually, you have to prove an equation. This figure will be given, you can see it is a amplitude modulated signal. Can you see this is an amplitude modulated signal?
Yes, sir.
Amplitude modulated signal. The signal will be given and you will be asked to prove modulation factor is equal to Vmax minus Vmin divided by Vmax plus Vmin. We don't know what is the Vmax here in the equation. Vmax means the maximum voltage of modulated signal, amplitude modulated signal. Listen up. Hey, be careful. We have 3 signals in each examples. Can you see? Carrier signal, message signal, modulated signal, right? Carrier signal, message signal, modulated signal, 3 things. Can you see? Carrier, message, modulated. So Vmax and Vmin actually referring to the modulated signal. Vmax is the highest amplitude and Vmin means what is the lowest amplitude. You get the point?
Yes, sir.
So again, sir.
Okay. What I am trying to say actually, you can see there is another equation. One equation we know of modulation factor. It's very simple. Actually, there are 3 equations of modulation factor. I'm writing it down. Then you will understand. Hello, M.
Yes, sir.
Another M. Another M. all are modulation factor, right? All are modulation factor. To find out this modulation factor, there are three equations. Number one equation we all know, that is amplitude change, change of what? Carrier wave. Then normal carrier
Amplitude.
amplitude.
Normal carrier
Normal carrier amplitude. Okay. First one is related with the amplitude change of the carrier wave divided by normal carrier amplitude. Okay. In second one, second equation is amplitude of the message signal divided by amplitude of the carrier signal. Look, same thing. First and two are same thing. Look, amplitude change is exactly equal with the amplitude of the message, right? Look at the, I'm giving you the proof. Look at here. In the first example, what is the amplitude change?
Zero,
Zero.
sir.
Zero. What is the message amplitude?
Zero.
What
0,
is the
sir.
amplitude change here?
1, sir.
What is the message amplitude?
A.
A.
A, that means 1, 1A.
Yes, sir.
Similarly,
Yes, sir.
what is the change? 0.5A.
1.5.
1.5
What
A.
is the message amplitude?
1.5
1.5.
What is the change? 1.5A.
1.5 A.
Message amplitude also 1.5A.
Yes, sir.
You get the point? এই আপনারা কেন বুঝতেছেন না? আমরা মেসেজের অ্যামপ্লিটিউড, আমরা এই মেসেজের অ্যামপ্লিটিউড অনুযায়ী তো পরিবর্তন করতেছি, তাহলে এই মেসেজের অ্যামপ্লিটিউড এবং পরিবর্তন তো সেম হবে, এটাই তো স্বাভাবিক,
Yes, sir.
Yes, sir. Yes, sir.
তাই না? সো দ্যাটস হোয়াই আই ক্যান রাইট ডিরেক্টলি অ্যামপ্লিটিউড অফ দ্য মেসেজ। আমার আর পরিবর্তন বের করার দরকার নাই, কারণ আই নো দ্য ব্যাকগ্রাউন্ড, হোয়াট উইল বি দ্য চেঞ্জ। ইট
Yes,
উইল বি
understood.
ডিরেক্টলি ইকুয়াল টু মেসেজ অ্যামপ্লিটিউড divided by amplitude of the carrier. Amplitude of the carrier means normal carrier amplitude, right? Hey, what do you mean by normal carrier amplitude? That means carrier amplitude. বুঝেন নাই?
Yes, sir. Yes, sir.
Yes, আমরা একটু অন্যভাবে লিখলাম। এতটুকু ক্লিয়ার তো? এই দুইটা ক্লিয়ার তো? একই জিনিস। ধরেন সেম পারসন, this time he is wearing suit and this time he is wearing Punjabi, but person is same. Okay, what about this one? Third one. The third equation is quite different. That is Vmax. Vmax minus Vmin. Vmax divided by Vmax plus Vmin.
Vmax plus Vmax.
Here the question will be
Vmax means that Vmax means big below voltage.
yes, yes.
Amplitude.
Actually, Vmax means the maximum amplitude. I am writing here with the terms of amplitude. Here, amplitude is the voltage level. You understand? This one. Suppose this is a signal. So this is the amplitude. So what is this amplitude called? This is actually the voltage level, right?
Yes, sir.
Okay. For your understanding, I am writing here amplitude max min, amplitude max min. Listen up. Vmax or amplitude max, Vmin or amplitude min is referring to modulated signal. Amplitude modulated signal. But in previous two examples, we were only considering message signal and carrier signal, right? Message and carrier, message and carrier. But third equation is related with which one? Modulated
Signal.
Now you get the point.
Yes, sir.
প্রথম দুইটাতে আমরা মেসেজ সিগন্যাল নিয়ে কথা বলছি, ক্যারিয়ার সিগন্যাল, এই দুইটা থেকেই ক্যালকুলেট করে মডুলেশন ফ্যাক্টর ওয়াজ ফাউন্ড। বাট ইফ ইউ নিড টু ইউজ থার্ড ইকুয়েশন, you have to look at the modulated signal. Modulated signal মানে আপনাকে এখন এই পাশের সিগন্যালটা দেখতে হবে। So Vmax means maximum amplitude of the modulated signal. Mean minimum amplitude of the modulated signal. Get the point?
Yes, sir.
And the interesting thing is here, look at the question. It says if the maximum and minimum voltage of an AM wave, can you see amplitude modulated wave are Vmax and Vmin respectively, then show the modulation factor M is given by this one. So actually they are asking you to prove M is equal to Vmax minus Vmin, Vmax plus Vmin. So we have to prove this equation. From where? From this figure. So it's the solution is given here, how they have proved. But we will learn the same derivation or same problem with a YouTube video. That will be more interesting, I think. Hello.
Yes, sir.
Yes, sir.
Can you
Yes,
see?
sir.
Yes, sir.
Yes, sir.
Okay, I'm running the video. Okay. What is modulation index or modulation factor? Same thing. Look. Is this okay? The definition they are giving? Modulation index is the ratio of the modulating signal voltage to the carrier voltage. Voltage they are referring to
Yes,
the
sir.
is that
Amplitude, sir.
okay?
Yes, understand, sir.
Okay, and in the second one, they are writing the equation. Modulation factor is equal to Vm, that means amplitude of the message divided by amplitude of
DC.
carrier.
Carrier.
Okay. Okay. Look, they have mentioned another point. Modulation index range. A modulation index means modulation factor. You get the point? একই জিনিস বলতেছে। Modulation index range should be, can you see should be? হওয়া উচিত।
Yes, sir.
It may be greater, but that is not good. ওইটা হওয়া উচিত না। Should be between 0 and 1. 0 and 1 means it should be in between under and critical modulation, not over modulation. Okay, okay. Look, for ideal modulation, Vm must be less than Vc. এটা কে বলতে পারবেন? Who can explain this term?
Sir, message signal mass less than, sir, carrier signal.
Why?
Because, sir, if we message signal is greater, then overlap is occurring.
Yes, if
Yes,
the
sir.
message is greater, then what
Sir,
will happen?
overlap, sir.
There will be, they're not overlapping. The term, actual term is there will be over modulation. Over modulation, that is the actual term, okay?
Okay, sir.
Okay.
Sir, here VC means carrier signal, sir.
Carrier signal amplitude. VC means carrier signal amplitude. VM means message signal amplitude. Look, it is given modulating voltage, carrier voltage.
Yes, sir.
You get the point?
Yes, sir.
Okay, we have one guest. Look, what happened if, look, what happened if modulation index is greater than 1? Therefore, what will happen? It will cause severe modulation called over modulation. You see, severe means অতিরিক্ত,
Yes.
তাই না? Can you see the figure here? Can you understand the figure? What is happening?
Yes, sir.
Yes, sir.
As a result, the waveform is, where is that? Near to the zero line. Due to this come, okay. Okay. Read out these 2 points. Are you getting the idea?
Yes, sir.
Pattern means here, this one. Near the zero line. Due to this, some of the information is lost. Okay. Then look at here. How to compute AM modulation index? Look, modulation index also be computed from the modulated wave itself. What we are talking about actually? From the modulated wave, how can we compute the modulation index? Try to get the point. Where is Vmin and what is Vmax? Try to get the point.
Yes, sir.
Is it okay?
Sir, maximum voltage, minimum voltage maybe.
Yes, Vmax means this one, top. And Vmin means this one actually, this level. Minimum voltage. And what you need to understand, how they have written Vmax is equal to Vc plus Vm. How they have written it.
So in carrier voltage and amplitude voltage, sir.
Carrier voltage and message voltage, sir.
You get this? How can they write this one?
Yes, sir.
Can they write this one? V mean is
Yes.
equal to Vc minus Vm.
Yes, understood, sir.
You understand?
Yes,
Okay. Then you have already proved it. Look. This is we can write. You told me. They can write it. They also can write it, right? Hey.
Yes, sir. Good, sir.
Vmax is equal to Vc plus Vm. Is this okay?
Yes, sir.
Yes, sir.
Vmin is equal to Vc minus Vm. Is this also okay?
এই জায়গাতে একটু ফাঁকা লাগছে স্যার
এই
বুঝলাম
জায়গাটা
না।
এটা VM minus VC হবে না স্যার?
No. Vc is greater.
স্যার
Carrier is
এখানে তো
greater.
দুইটাই তো মাইনাস হওয়ার কথা স্যার ভিসি এন্ড ভিএম
Yes, sir.
দুইটাই ভিসির দিকে
Yes, sir. দুইটাই minus হওয়ার কথা।
So you are confused now. Okay, well.
ইয়েস স্যার
Now I have to here I have to write spinning tool, SPNI, snipping tool, sorry. Oh, sorry, SN. I have to cut that figure. What is that? It takes some time to open this app.
Sir,
স্যার ইন মিডল মেবি স্যার ব্রাউজার
Okay, open, right?
hello, sir.
I'm listening.
Sir, I need a break, sir, to take breakfast. I already done the 3 class in a room. I don't take my break.
I'm not listening.
Yes, sir. Need a break.
Okay, now it's appeared. This one. I need to cut this thing. Okay. Can you see it?
Yes, sir.
Okay, okay, okay. Wait,
Sir, what is the software name you are using it? What is the name of the software, sir?
not software, it's the tool. This one is snipping tool.
Okay, thank you, sir. This.
Snipping tool. It's built into all the window.
Oh, okay, sir. Okay, sir.
Okay, listen. Hey, this signal is a modulated signal. Modulated signal.
Yes,
Right.
sir.
Yes, sir.
Can you see there is a line here?
Yes, sir.
Yes, sir.
So what is this thing is referring to?
Sir,
This is
carrier oil.
referring, this was the carrier. This was the carrier, right?
Yes, sir.
ক্যারিয়ারটা এরকম
sir.
ছিল, এরকম সমান ছিল. Is not it?
Yes, sir.
Yes, sir.
This one. This line I am referring to. Probably you understand. This was the carrier. Okay. So if I ask you what is carrier amplitude, then you will go from zero line to here, right?
Yes, sir.
This is the
Yes,
carrier.
sir.
Again, I can call you. This is also carrier amplitude, right?
Yes, sir.
Yes, sir.
This is written here. Look, VC. Can you see?
Yes, sir.
Yes, sir.
Carrier amplitude. Up to this line is the carrier amplitude. We are clear, I think. Okay. Now look. This was the carrier amplitude. Now, from this carrier level up to this is the message, is not it?
Yes, sir.
Yes, sir.
With different color, I think it will be better. Here, this is the message. This is better. Huh?
Yes, sir.
Yes, sir.
Up to this is the message. We are clear?
Yes, sir.
Okay. Look at here. From this to here, it is also the message.
Yes, sir. Now it's clear, sir.
Is it clear?
Yes, sir. Yes, sir.
Also the message. Can you see the message has positive amplitude, negative amplitude? So if this one is the message amplitude, it will be also the message amplitude. It is A, it will be also A, right?
Yes, sir.
Yes,
We
sir.
are considering sine wave actually to reduce the complication. You get the
So now
point?
it's- Yes, sir. Got the
Yes, sir.
point.
Okay, so can you tell me? Okay, listen. Now, what we need actually, we need V max, is not it? We need V max. আমাদের V max দরকার না?
Yes, sir.
Hey, V max means from this zero line to the top, right?
Yes, sir.
So up to this is the carrier signal, right? Up to this is the carrier amplitude. And from this to the top is the message amplitude. So if you sum up the message amplitude and the carrier amplitude, you will get the Vmax. Is it clear?
Yes, sir.
Yes, sir. Clear.
So that is what they have written here. Vc plus Vm is Vmax. You understand?
Yes,
Yes,
sir.
sir.
Okay, now we need another thing. V min.
Mean.
We need V min. Okay, let's find what up to which portion is V min. কতটুকু V min আগে দেখেন। এই যে এতটুকু V min, right?
Yes, sir. Got it.
Only
Yes,
this one is V min. Only this segment is V min. So if you subtract the message from the carrier, the remaining item is V min.
Meaning.
See,
Yes, understood.
এই যে এতটুকু হচ্ছে ক্যারিয়ার, আর এইখান থেকে এতটুকু হচ্ছে মেসেজ, আর এইখানে এতটুকু হচ্ছে ভিমিন. So if you subtract Vm from Vp, what you will be getting? You will be getting this item.
Yes, sir.
Hello.
Yes, sir. Understood, sir.
সবাই বুঝছেন?
Yes, sir.
আচ্ছা, আমি তো রেসপন্স পাচ্ছি না. Probably many of you just joining here and doing your stuff.
স্যার গতকাল ভাইবা দিয়ে শেষ করছি স্যার।
স্যার
Yes?
ব্রেক না স্যার আপনি একটু তাড়াতাড়ি
স্যার একটা ব্রেক আছে আজকে একেবারে ক্লাস নিতে
স্যার
পারেন
একটু
স্যার।
তাড়াতাড়ি দাঁড়িয়ে যান
Hey,
স্যার, ব্রেক
আর
দরকার
একটা
নাই।
ব্রেক দেন স্যার।
how many viva you have given?
We need break, sir.
স্যার 6 ভাইবা।
6 viva. That means 1 hour, right?
হ্যাঁ স্যার
স্যার
পড়ালেখা
We
করতে হইছে তো
continue
স্যার।
with 10 minutes. I have
ইজ ভাইবা পেন স্যার 1 ডে স্যার।
I have spent how many? I think 5 or 6 hours of taking viva yesterday.
স্যার আপনার অনেক কষ্ট হইতেছে স্যার, আপনার ছুটি দেওয়া উচিত।
Please,
No, I'm
এত কেন
okay.
কষ্ট করা দরকার
আপনারও
আছে?
রেস্ট নেওয়া উচিত
আইইউবিতে
স্যার।
Okay, I will
তো একটু
give you
রেস্ট
a
নাও।
break. Okay, I need you need
স্যার ব্রেক না
break.
স্যার আপনি
স্যার ব্রেক
স্যার
শুট দিন স্যার,
একবারে শেষ
নেন
করে
স্যার।
দেন স্যার এখনই।
Yes, sir.
এই আমাকে এই ধরনের রিকোয়েস্ট করা যাবে না।
স্যার আপনি 12টা পর্যন্ত চালান স্যার।
স্যার স্যার স্যার
Listen
স্যার
up.
আপনার স্যার একটু রেস্ট নেওয়া দরকার স্যার।
We
স্যার
have
আপনার
to
স্যার রেস্ট নেওয়া
utilize the class time. শুনেন, আমি এই যে এইটা একটু শেষ করে I will give you a short break and then we will start some interesting items, topics. And one announcement, এটি একটু আগেই দিয়ে দিই। In 28th of February, do you have any class Sunday?
নো স্যার,
No?
নো স্যার।
Okay. Then no announcement.
I have class sir.
Okay, we'll discuss about it because I have to go to university for a official work. So I don't know how can I manage the class schedule or time. Probably I need to take that makeup on
Which day you will go sir?
সানডে উই হ্যাভ নো স্যার, নো
Which day
ক্লাস
you
স্যার।
will go?
মানডে এন্ড টুয়েসডে স্যার।
Okay, anyway, then no problem with this section.
ইয়েস স্যার।
Hey, I need your 100% attention for next 2 minutes and then you will get a short break because what I will be
Yes, sir.
explaining now is very, very important for midterm. Okay.
ইয়েস স্যার।
20 minutes short break sir.
Okay. I hope you understand how they have written these two equations, Vmax and Vmin.
ইয়েস স্যার,
Yes, sir.
আন্ডারস্ট্যান্ড স্যার।
From this figure, without this figure, these equations are valueless, right?
ইয়েস স্যার।
Okay, you have to must draw this figure to validate this equation. Okay, anyway, look at here. After subtracting equation 1 and 2, what you will get?
2 PM।
Vmax minus Vmin. That means
Plus 2 pm.
what will happen? VC will be cancelled out, right?
ইয়েস
Yes,
স্যার।
sir.
And you will get 2 Vm, right?
ইয়েস
Yes,
স্যার।
sir. Equal Vmax
Oh.
minus this.
Vmax minus Vmin. Okay, anyway. Now, after adding these two equations, what will you get? Tell me. After adding these two equations,
Sir 2 VC sir.
2 VC, right?
ইয়েস স্যার।
2 Vm, 2 VC. Like this one. 2 VC will be Vmax plus Vmin. Now, let's divide. Let's divide the subtraction and addition equation. Then what you will get?
Sir
2
পাবো
will
হচ্ছে
be cancelled out, is not it?
yes sir.
2 will be cancelled out. That means you will get Vm divided by Vc is equal to Vmax minus Vmin, Vmax plus Vmin. Clear?
Yes, sir.
Now tell me, Vm by Vc is equal to what?
MA. Sir,
Modulation of
মডুলেশন ফ্যাক্টর।
gaseous
modulation.
amplitude divided by carrier amplitude. এটার মানে কি?
মডুলেশন ফ্যাক্টর।
Modulation factor. So modulation factor is equal to Vmax minus Vmin divided by Vmax plus Vmin. Is it true?
আন্ডারস্ট্যান্ড স্যার। ইয়েস
You
স্যার।
understand? Okay. Same thing. Okay. Same concept was proved here. Same thing was proved here. Same thing. You get the point?
ইয়েস স্যার।
Yes, sir.
Okay. Now. এই দুইটা
But how, sir, how they divided by 2, sir?
Okay, they have the logic from this figure actually. if you look at the figure carefully, then you can relate how they have written in this way. Same
Yes,
thing,
understand.
same thing. Okay, listen up. এই যে এই দুইটা ম্যাথ কিন্তু বিশাল, বুঝছেন? দেখেন কত বড় ম্যাথ,
ইয়েস স্যার।
লাইনে শেষ।
স্যার কিন্তু ছোট্ট একটা কোশ্চেন ছিল স্যার,
Yes, yes.
এই পিডিএফটা তো নাই স্যার আমাদের কাছে।
It's given in the Google
স্যার
Classroom.
আছে স্যার,
Yeah,
আছে
আচ্ছা,
স্যার,
আচ্ছা। তো
আছে,
ওই
আছে,
ভিডিওটা
এই,
স্যার
সাবিরুল তুমি দেখো নাই,
লিংকটা
দেখো নাই
ক্লাসরুমে
তুমি।
আছে স্যার।
আমি তো
স্যার
খুঁজে
ভিডিও
পাই নাই
লিংকটা স্যার।
Oh, video.
স্যার ভিডিও লিংক।
Yes, স্যার
Okay,
যেটা বুঝাইছেন স্যার।
I'm giving it now. It's simple video. You can when
ভিডিও
you
লিংক বোকা ছেড়ে দেখে নাই।
look here, the link is given.
ওকে স্যার।
এই শোনেন, এই দুইটা ম্যাথ করেই আপনাদের ব্রেক। ম্যাথ আসলে এটা ম্যাথ না, এটা হচ্ছে শিশুতোষ একটা কি বলে প্রবলেম। দেখেন শিশুতোষ বলতে কারণ ইটস ভেরি সিম্পল।
ইউ আর প্রফেশনাল স্যার।
ম্যাক্সিমাম এই example 16.2, the maximum peak to peak voltage of an AM wave. Remember, peak to peak voltage of an amplitude modulated wave is 16 millivolt and minimum peak to peak voltage is 4 millivolt. Calculate modulation factor. Listen carefully. You have to calculate modulation factor and you have given
আই থিংক স্যার এমএ স্যার।
you have given some information about the modulated wave. Modulated wave means you have no option but use this equation, right?
Yes, sir.
Okay, and what are the information given? Peak to peak voltage. Now let's look at what is called peak to peak voltage.
স্যার হাই মানে সর্বোচ্চ বেগটা স্যার।
Vmax means from 0 to the top.
Yes, sir. Upper peak and lower peak, sir.
And peak
Both,
to peak
sir.
means this position to this position.
ইয়েস স্যার।
Yes,
So,
sir.
ইয়েস স্যার।
actually, peak to peak voltage is the double of Vmax.
ইয়েস স্যার।
Yes, sir.
And peak to peak minimum means the double of Vmin. You
Yes,
understand?
Yes,
So,
Yes, sir.
so how they will calculate it? Look, in this figure, Vmax will be 16 by 2.
Yes, sir.
Why 16 by 2? You understand?
Yes,
স্যার
sir.
ডাবল
Yes,
স্যার।
sir.
Because the double is given, we need half, 8 millivolt. Minimum voltage, 4 is given, double, we need half, that means 2 millivolt. Now, modulation factor, very difficult calculation, you know. There are some subtraction and addition.
Yes, I understand, sir.
Very difficult, right?
Yes,
No,
sir.
sir. Easy,
Very
easy,
difficult.
sir.
And what about number 3? A carrier of 100 volt, a carrier of 100 volt and 1200 kilohertz is modulated by 50 volt 1000 hertz sine wave signal. Find the modulation factor. এইখানে তো দেখেন একটু ঝামেলা করে দিছে না?
Sir, kilohertz দিয়ে স্যার ঝামেলা করতে স্যার, কিন্তু এটা লাগেই নাই স্যার।
এটার কোনো প্রয়োজনই নাই, এটা আপনাকে বিভ্রান্ত করার জন্য দিয়েছে। These are not unnecessary information. You need to find out modulation factor. Modulation factor findings এর জন্য we know 3 equations. আমরা তিনটা ইকুয়েশন জানি, is not it?
Yes, sir.
Yes, sir.
We know 3 equations. So the information given, কি কি দেয়া আছে? Carrier amplitude is given, message amplitude is given. Message amplitude is given. So very simple. Modulation factor is message by carrier.
Message by carrier.
So 50 by 100, that means 0.5. Hello, hello.
Yes, sir.
Yes, sir.
Okay, so and the next after break we will start from this analysis of amplitude modulation. Okay.
Okay,
Now it
okay,
is
sir.
It will be long, sir.
7. ধরে নিলাম 12টা বাজে, okay? 12. You
12টা
will
10, sir.
at
না
12.
স্যার 12টা 15 স্যার।
12:10.
না স্যার
Yes, sir.
15
এই আরো 3 মিনিট এখানে এক্সট্রা আছে।
Yes, sir.
Come back at 12:10. Are you there? I can see only 12 students.
Yes, sir. Yes, sir.
Yes, sir.
Break time is over. Okay, let them join. Let's wait another 1 minute. Okay, let's start.
Yes, sir.
20. Jahangir Alam now join on after 1 hour. More than 1 hour. Okay. Okay, from this slide, we have completed up to space
This,
wave
sir.
propagation. This one, right?
Yes, sir.
Space wave propagation. Okay. And after that, there are some calculation of height of the transmitting antenna. Next class, we will be discussing about this one, height of the transmitting antenna, this one, a mathematical problem, MCQ, antenna, and need for modulation, power radiated by antenna, mixing up the signal. So these things will be covered in the next class, inshallah. Today, we are going to start here. Here means the mathematical expression of amplitude modulation.
সাকিবুল স্যার
Since
সাকিবুলের মাইক্রোফোনটা একটু মিউট করতে বলেন।
okay, Sakibul muted his microphone. Okay. What I am trying to say, since we are studying modulation factor, amplitude modulation related topic, so today I think it will be better to start with the mathematical representation of the amplitude modulation. How the equation will look like after being modulated. Okay. Let's start from here. Hello. You already know this. Modulation. Modulation is the phenomenon of superimposing low audio frequency baseband message or information signal on high frequency wave called carrier wave. So the summary of this definition is modulation is a process of superimposing low frequency message signal with the high frequency carrier signal, right? Hello.
Yes, sir.
Yes, sir.
Okay. And after modulation, the wave you get, that means resultant wave, is called modulated wave. It is also clear, right?
Yes, sir.
Okay. And from this side, you can see the figure. Here is a message signal. Can you see? It is a signal, message signal.
Yes, sir.
And the carrier signal is not drawn here. I am drawing it for you. This is the carrier, for example. This is the carrier signal. Message and carrier with fixed amplitude. And look at this one. What type of modulated signal this is?
Amplitude modulation.
Amplitude modulation, AM. It is according to the message. Can you see the variation is exact same with the message signal?
Yes, sir.
And this one is the FM modulation, amplitude
Yes,
fixed, but frequency is changing. For the positive half cycle, for the positive peak or positive value in the message, frequency is high. Can you see here the frequency high?
Yes, sir.
For the negative, frequency is low. Can you see low frequency?
Yes, sir.
Again positive half cycle, again high frequency. So this one is called FM. We know this. These are already discussed in the first term syllabus, I think.
Yes, sir.
Hello.
Yes, sir.
এগুলো নিয়ে কথা বলা হয়েছে আগে, right?
Yes, sir.
জি, স্যার।
Okay.
পরীক্ষাতে আসছিল স্যার এগুলো।
Yes, yes. You know, there are three types of modulations: amplitude, frequency, and phase. We all know that these things. It's already studied. Look at look here. The amplitude modulation. What is amplitude modulation? The amplitude of the carrier wave varied. That means change in accordance with the amplitude of the modulating signal. Modulating signal means message signal, is not it?
Yes, sir.
And you can see here, this is the message signal, this is the carrier signal, and here is the modulated signal. You see? This one
Yes,
and
sir.
this one, the variation is same according to
Sir,
the
modulating signal means message signal, sir. It is
modulating means message. Modulating, that means who is participating in the modulation process.
Yes, understand, sir.
That means message. Okay. However, the frequency of the amplitude modulated wave remains the same as the carrier wave. You understand the meaning?
Yes,
Here,
sir.
the frequency is same of the carrier. There is no change in the frequency. You understand?
Yes, sir.
Only change in the amplitude level, in the amplitude according to the message signal. Very basic concept of amplitude modulation. Clear?
Yes,
Yes,
sir.
sir.
Okay, now এইবার এখানে আসেন, এটাই আমাদের আজকের পড়া। Amplitude modulation. Look, in here, we have just shown a signal like this. We have shown a signal like this. আসলে এই সিগন্যাল গুলা mathematically with equation we can represent, right? We can represent this signal mathematically through equation. In this slide, you can see how they are representing the message signal. Can you see the message signal?
Yes, sir.
And this message signal is represented with this equation. MT message signal is equal to AM sine omega MT. Sine wave, you understand?
Yes, sir.
Yes, sir.
So if I don't draw this signal, if I only write this one, what you will understand? There is a signal like this. You understand?
Yes, sir.
Sir,
Yes,
sine
sir.
wave signal, sir.
Okay. Similarly, look at here. Carrier signal will be represented with this equation now. আপনারা এখন এই সিগন্যালের এইগুলা দেখবেন না, আপনারা এখন ইকুয়েশন দেখবেন।
Yes, sir.
You will see the equations. Look, similar type equation, okay, similar type. AM sine omega MT, AC sine omega CT. Now tell me, what is this AM? This AM means the amplitude, right?
It's amplitude of the message signal.
Amplitude of the message signal. AC, amplitude of the
Carrier.
Carrier signal.
You understand? This
Yes,
one.
sir.
AM and AC, they may vary, right? If these two are equal, AM and AC, these two are equal, that means it will be a critical modulation factor, right?
Yes, sir.
Which one is better? Tell me. AM
Sorry,
less than
AM
AC
is less
or
than
greater than AC?
AM less than AC, sir.
AM less than AC is better. Yes. Okay. What about omega M, omega M, omega C? Omega M represent angular frequency.
Yes, sir.
Omega C represent angular frequency. This one omega M for the message signal. This is for the carrier signal. And you know, in the angular frequency, omega is can be written as twice pi f.
Yes, sir.
So actually, inside this omega, there is the frequency component of the signal. Hello.
Yes, sir.
What I am trying to say
Sir.
is any signal, in any signal, there are some special parameter. What are the parameter? Like amplitude, like the frequency, phase. You understand? These are
Yes.
the
Yes, sir.
important characteristics of the signal. So amplitude of the signal is represented by this term only, AM. AM দ্বারা কি বোঝায়?
Amplitude.
আপনি যদি AM এর মধ্যে চেঞ্জ করেন তাহলে কি হবে? Amplitude will be changed, right?
Yes, sir.
এই AC তে চেঞ্জ করলে কি হবে বলেন তো?
Carrier to change.
Carrier amplitude will be changed. এখন আপনাকে আমি যদি বলি you have to change frequency, where you will change? Tell me.
Omega, sir. Angular.
You will change here only, inside the omega M, right? Hello.
Yes, sir.
কারণ ওমেগার ভিতরেই তো frequency. Can
Yes,
you
sir.
see?
2 pi f.
Equation 2 pi. Okay. If I ask you to change phase, you have to change omega mt, omega ct with t, right?
Yes, sir.
Yes, sir.
So can you remember in previous case, amplitude modulation, frequency modulation, phase modulation, actually amplitude will be changed for this one. For frequency modulation, frequency will be changed, and last one, phase will be changed. These are the difference, right?
Yes, sir.
So from the equation for AM, where the change will take place? Here, for AM. For FM, where the change will take place? Inside the omega C. For PM, phase modulation, the change will be taken place where? In this omega ct whole unit. You understand?
Yes, sir.
Yes, sir.
So we are studying what? Amplitude modulation. So
Modulation.
where the change will take place?
Amplitude.
AM.
AM or AC?
Yes, sir.
AM, sir.
AC sir. AC sir.
Think. What is
Sir,
the
AC.
definition of amplitude modulation? The amplitude
AM.
of the carrier signal. Amplitude of the carrier signal will be changed
Yes, sir.
according to the message signal. So according
AC
to
will
this
change.
signal, this whole signal, amplitude AC will change. You clear?
Yes, sir.
No, sir.
No? Hey,
Yes, sir.
Yes, sir. Amplitude change,
we are
sir.
studying amplitude modulation. The definition of this is
আর amplitude এটা তো জানি স্যার amplitude টা চেঞ্জ হবে কিন্তু
আর
আপনি
amplitude change হবে. Which one?
Sir, carrier wave.
Carrier
Sir,
amplitude will
carrier wave sir.
yes sir yes sir
So
yes sir yes
carrier wave এর amplitude কোথায়? AC.
see
Yes, sir.
That means this AC will be changed. How? কিভাবে চেঞ্জ হবে? এই সিগন্যাল অনুযায়ী, AM অনুযায়ী, right?
Yes, sir.
Okay, now look at here. Look at the next page. You will understand it now. Look, very simple. This is actually AM signal. This is the AM signal. AM signal. AM signal is this one. Try to understand. Is it okay or not?
Sir.
এই মনোযোগ
Sir,
দেন।
Sir,
next
sin
time আমি
omega c
sin
common,
omega
sir.
আসলে স্যার
সেটা তো ভিতরে হবে, স্যার।
Listen
না।
up. এই শুনেন। can you remember what was the
Yes sir, carrier modulation এবং স্যার
AC
frequency
sin omega CT? This is the
CT.
carrier, right?
Yes
Yes, sir.
So after modulation, AC will be changed. AC
Yes,
will
sir.
change means there will be addition and subtraction with the message signal, is not it?
Yes, sir.
Yes sir.
কথা কি বোঝা যাচ্ছে? So
Yes,
এই যে
sir.
দেখি, এই যে with the AC,
Yes,
with
sir.
AC amplitude, the whole message signal is added. Can you see? And
Yes, sir.
Yes, sir.
now all of this segment AC plus AM sin omega t is acting like the amplitude of this signal, right?
Yes sir, understand sir.
And rest of the thing is same. ক্যারিয়ারের বাকি বৈশিষ্ট্য সেম। দেখেন ওমেগা সি চেঞ্জ হয় নাই, টিও চেঞ্জ হয় নাই।
Yes sir.
Yes, I understand, sir.
আপনারা কথা বুঝতেছেন? আমরা শুধু এসির সাথে যোগ করে দিয়েছি এমটি কে। That's it.
Yes sir.
Now
Yes.
you can say, sir, why add addition? Why not subtraction? So actually, if MT is negative, then automatically it will be negative. Plus minus will be minus. বুঝেন নাই?
বুঝছি স্যার।
বুঝতে পারছি স্যার।
Okay, okay. Now let's take common AC. AC common নেন। AC common নিলে AC বেরিয়ে আসবে। There will be one, right?
Yes sir.
And এই সেগমেন্টে কোনো AC আছে? No.
না স্যার,
That's why it will be divided. You understand?
Yes, sir.
And this is remain the same like before. আগের মতোই আছে। Okay, okay, okay. Now look at here. AM by AC. Is it familiar to you?
Yes sir, MA.
Yes, sir.
AM by VC. It is actually modulation index. That means modulation factor. So
Yes,
let's
sir.
write it in this way, mu. This one. আমরা এটাকে mu লিখি এখন, m না লিখে, হ্যাঁ?
Okay sir.
Yes, sir.
Okay, so can we write actually this CMT, এটা হচ্ছে AM, আপনাদের কনফিউশন দূর করার জন্য AM. AM is equal to, let's multiply. আপনি এই যে AC sin omega CT এই দুইটা দিয়ে ভিতরের গুণকে গুণন করে দেন, গুণ করে দেন. What you will get? AC sin omega CT for this one. And mu sin
Yes,
omega MT sin omega CT, and there is
Yes,
AC, another AC, right?
Yes sir.
গুণ করে দিছি
Plus
আর,
হয়ে গেল, sir.
হ্যাঁ?
Plus
Sin
একটা
omega
আছে।
t plus, sir.
Here is plus.
Yes, sir. Understand.
You understand? Just গুণ করে দেয়া হয়েছে।
Yes, yes.
Okay. Now, who can tell me how they have written this equation?
সাইনে সাইন বি এর সূত্র দিতে স্যার।
Yes, sin A, sin B formula. You know this formula?
Yes,
Sin
sir.
A, sin B.
Yes,
I
sir.
think better than because you are doing, you have done these math courses recently.
Yes, sir. Yes, sir.
Okay, let me find out. Here is the formula. Okay, I'm closing it. It's opening with Photoshop preview. Oh no. No. Where is the open with? Open with. Oh, here is the open with. Photos. I have downloaded the image of this formula. Hey, can you see the formula?
Yes, sir.
Yes, sir. Yes, sir.
Write it down. You may forget it. When you will be sin A, sin B, this one, top one. Cos A minus B minus cos A plus B divided by 2. Written?
Yes, sir.
Yes sir.
Okay.
Screenshot, sir.
Okay, anyway, thank you. screenshot, but in your khata it will be more effective. Now we can write these things, right? Sin A sin B, that means cos omega c minus omega mt minus cos omega c plus omega mt. Okay, let's go to the next slide. Here, hey, listen up. কি করা হয়েছে বলেন তো? ওইভাবেই রাখা হয়েছে।
টুটাকে সাইডে আনা হয়েছে স্যার।
হ্যাঁ হ্যাঁ, so look, in this equation we can see three segments. আপনারা তিনটা সেগমেন্ট দেখতে পাচ্ছেন?
Yes sir.
Yes,
three,
sir.
three units, okay. And in these 3 units, how many frequency you can see? How many frequency are there? Look, one is omega c,
Yes, sir.
right?
Yes, sir.
Yes sir.
Omega c. Another one is omega c minus m. Another one is omega c plus m. Can you see?
Yes, sir.
Okay, look, here some information is written. Carrier wave frequency omega c is there. আচ্ছা, তার আগে আমাকে একটু বলেন, actually this signal is the AM wave, right?
Yes, sir.
This signal is the AM signal, there is no doubt. And in this AM signal we can see there is a presence of carrier frequency. There is a
Yes, sir.
presence, there are some other frequency segment also present, like omega c plus omega m, omega c minus minus omega m plus omega m. So here it is written, there the carrier wave of frequency omega c plus 2 sinusoidal wave, one frequency omega c minus omega m, another of frequency omega c plus omega m. So those two additional wave, this one and this one additional, are called side bands. এদের একটা নাম দিছে, এরা হচ্ছে side bands. You understand? And their frequency are called side band frequency. একেবারে সহজ করে বলি, this is the equation for AM wave, and after analyzing the AM wave, you can see there is a presence of omega c, that means carrier frequency, with two other frequencies like omega c minus omega m, omega c plus omega m. So this plus minus, these two frequencies are called sideband frequencies. এটা একটা নাম দিছে side bands, এটা একটু মনে রাখতে হবে আপনাদেরকে।
Okay, sir.
Okay, so can you see one sideband is greater than omega c, another is lower than omega c? মানে এটা যদি
Yes,
omega
sir.
c হয়, one is upper, another one is lower. You understand?
Yes, sir.
Yes sir.
Okay. And here is a graph, and this graph is very interesting. Look, this x-axis is representing the frequency. Oh, you will see it. আপনি এখনই দেখবেন. In this graph, you can see there is omega in x-axis, in y-axis, that is the amplitude in y-axis. Okay, y-axis
sir.
is the amplitude A. Okay, so look, for AC amplitude, when it is AC, for AC, what is the frequency? Omega c, right?
Omega c. Yes
So
sir.
look, for AC, this is the omega c. Can you see?
Yes sir.
Yes, sir.
Okay, and we have two more frequencies. One is omega c minus m. Omega c minus m will definitely in the left side,
Yes
right?
sir.
It is lower.
Yes, sir.
And omega c plus m, it is greater, it will be in the right side. And both of these side bands are sharing same amplitude, mu AC by 2, right?
Yes, sir.
This is the mu AC by 2. Actually, mu AC by 2 is the amplitude for the lower side band and the upper side band, both. সহজ না একেবারে?
Yes, sir.
Okay. Now,
Sir, 5 minutes left, sir.
huh?
5 minutes
No more
left.
2
sir.
days sir.
Okay.
Sir, 5 minutes left.
You go. Hey, this is the last slide. This is the last slide. Look, this figure you understand, I hope. Hey,
Yes sir.
Yes, sir.
Yes sir.
okay. Can you remember bandwidth?
Yes sir.
Yes sir.
Yes, sir. Maximum range of the
Range of
frequency.
frequency, where the signal
Maximum range of frequency.
maximum range of frequency. Now tell me, out of these three frequency point, here is one, here is another, here is another, what is the range from this point to that point, right?
Yes, sir.
Yes,
So
sir.
how can you calculate this range? That is what is mentioned here. Very simple.
By adding, sir.
Yes, frequency of lower side band is omega c minus omega m, এটা আমরা আগেই জানি। frequency of upper side band omega c plus omega m. So the bandwidth of the amplitude modulated wave, এই যে দেখেন কি নিয়ে আসছে এখানে, bandwidth, the bandwidth of the amplitude modulated wave is, এই যে বড়টা থেকে ছোটটা বিয়োগ করতে হবে, তাই না, ডিফারেন্স। ধরেন একটা বলছে 10, another one is 6, what is the bandwidth in between 10 and 6? 4. So this is what you have calculated, upper minus lower. So if you subtract LSB, lower side band, from the upper side band, you will be getting 2 omega m. You understand?
Yes, sir.
Yes,
Understood.
sir.
So 2 omega m is the bandwidth of AM modulated wave.
Sign type of color.
So বুঝতে পারছেন?
Yes, sir.
Yes,
Sir,
sir.
কিন্তু
Yes,
sign
sir.
type minus থাকবে, sir.
No.
I
Look,
was again frequency.
upper side band is before. Hello.
Yes, sir.
Yes, sir.
So only frequency, sir.
Upper side band আগে
W theta বাদ যায় স্যার।
Yes, sir. Yes, sir.
ওকে,
Yes, sir.
আমার মনে হয় আপনারা ধরতে পারছেন।
Yes, sir.
এখন দেখেন তো বিশাল এক ম্যাথ।
স্যার আজকে আর না স্যার,
এই
আচ্ছা।
এটা শেষ, এটা এখনই শেষ, এটা করতে 0.5 সেকেন্ড লাগে। amplitude of the message given, amplitude of the carrier given, what is modulation index? AM by AC, yes, simple. দেখছেন?
আপনি তো বিশাল ম্যাথ বলছেন এখনই।
হ্যাঁ না, বলছি যাতে আপনারা মনোযোগ দেন। Okay, I am at